Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC 403. Topic Gauss law. Gauss law constitutes one of the Maxwell's equation, and it is a fundamental laws of electromagnetism. Gauss law states that electric flux through any closed surface surrounding the charge is equal to the amount of charge enclosed by the surface. Consider a closed surface. The electric flux through any closed surface. The closed surface is surrounded by a charge. The electric flux through any closed surface surrounding the charge is equal to the amount of charge enclosed by that surface. This is the statement of Gauss law. Here, the type of surface is closed surface. It is a closed surface. So, from the statement of Gauss law, the electric flux is equal to closed surface integral of differential electric flux, and by the definition, closed surface integral of d dot ds, and it is equal to the amount of charge enclosed by the surface. The electric flux through any closed surface surrounding the charge is equal to the amount of charge enclosed by the surface. It is equation number 1. And equation number 1 is the statement of Gauss law, where uh, d is equal to 1 by 4 pi q by r square ar cap. Equation number 2, along the radial direction, the differential normal surface ds is equal to r square sine theta d theta and d phi along radial direction. To prove the statement of Gauss law, you're supposed to remember the equations 2 and 3, where the value of d is derived from epsilon e. The general equation for electric field is already given in the earlier lectures. Now, the electric flux is equal to closed surface integral of d dot ds. It is equal to closed surface integral d is equal to 1 by 4 pi q by r square ar cap dot product differential normal surface ds is equal to r square sine theta d theta and d phi along the radial direction. Now here theta is colatitude ranging from 0 to pi, and pi is from 0 to 2 pi. For more details, refer to the video lectures on coordinate systems. Now here by expanding AR dot AR is equal to 1, and this can be simplified as theta is from 0 to pi, pi is from 0 to 2 pi, AR dot AR is equal to 1 by 4 pi q by r square sine theta d theta and d phi. Now r square gets cancelled, and the integration of pi is from 0 to 2 pi d phi is equal to 2 pi, and by neglecting the integration of pi, it will become theta is from 0 to pi 1 by 4 pi sine theta d theta, and the pi integration is 2 pi cancels q by 4 pi, it will become q by 2. The electric flux, let us continue to the next page. Electric flux is equal to theta is from 0 to pi, q by 2 is constant, sine theta d theta, and it is equal to q by 2 minus of cos theta. The integration is ranging from 0 to pi, and after substituting the lower and upper limits, we get uh, the electric flux is equal to the amount of charge. Once again, I will write the equations. The electric flux through closed surface is equal to the closed integral of d dot ds is equal to q. It is a statement of Gauss law. Once refer to the equation. Uh, Gauss law in differential form. Gauss law in differential form. Just now we discussed from the statement of Gauss law, the electric flux is equal to closed surface integral of d dot ds is equal to the charge. Let it be some equation number 2. Now apply divergence theorem. The closed surface integral will become volume integral, and del dot d bar dv is equal to, and from the definition of charge distribution, the charge is equal to the volume integral of rho v dv. Let it be equation number 3. Here from equation number 3 we can write del dot d bar is equal to rho v. It is one of the Maxwell's equations, and you have to make a note regarding the definition of Gauss law. That is, the electric flux is equal to closed surface integral of d dot ds is equal to the electric charge. But here, in simple uh, surface integral of dds, the electric flux is equal, the simple surface integral of dds is not equal to q. You have to make a note. When the surface integral is closed integral, then only you can write it as uh, q, otherwise it is not equal to q. Once again I will repeat the statement of Gauss law. The electric flux through any closed surface surrounding the charge is equal to the amount of charge enclosed by that surface. Refer to sample problem. It is based on differential form of Gauss law. The value of d is given. You are supposed to calculate del dot d, and then you have to apply the volume integral to determine the amount of charge enclosed by the surface. Refer to one more problem. Refer to practice problem. You can follow the same notation to solve the problem. Thank you. We will meet with the next lecture.